Hello, Worthington Juniors. I'm back. Okay, just had a nice little lunch and ready to do another instructional vignette on linear equations. I think there should be a string in me going in and out because I've been doing the same lesson quite a bit, I think. There are three major linear equation forms that you guys are going to run into when you look at the state exam, or how can a linear equation look to you. And I'm going to review those. Probably the thing that's different about this lesson is we're going to write linear equations based off the graph of the line. That's why they're called linear equations. They form a line. Now how can I take that information and actually make an equation out of it? So it's somewhat in reverse of what we normally are asked to do, where we have an equation and we say, all right, let's graph 4,000 of those. Okay, so here we go. Write an equation for the graph line, and our go-to equation model is slope-intercept form. Slope-intercept form, which is, for the 20th time, y equals mx plus b, where b is the y-intercept of the line, okay, where it crosses the y-axis, and m represents the slope or the slant of the line with rise and run. So, looking at this particular line, we can make an equation in short order because you can see it. The y-intercept is right here. It's at positive 2. The slope, we're going to use the idea of rise and run. Rise, I get to go from a corner point to a corner point. Rise 2 and run, it's like 5. So the slope of this thing is m is 2/5, and the y-intercept's at negative 2. So we should be able to say y equals slope 2/5 times x, 2/5 x minus 2, or negative 2. There you go. So slope-intercept form, when you got a graph and you can see the y-intercept, you can see the slope, that's pretty easy to plug into that one. All right, now, another one that's related is called point-slope form. You're not going to see this one as much because it's not as pretty a form, but it's actually pretty easy to write an equation for, because what it says is take any point on this line, any point anywhere, and the slope, okay, get it, point, slope, and you could have an instant equation. So it says take any point you find, call it x1, y1, and just plug that into this model. So y minus y1 is m times x minus x1, and you can have an equation for the line. And it's true, okay? So, say for instance I took this point right here, which is 5, 0, and I said, okay, that's a point I can see. I certainly don't need the y-intercept point plus the slope to make a line. The only reason I need it here is because it's a requirement of the form. I need the y-intercept point, that one special point. You certainly don't need that to graph a line. So, using this, I would have y minus the y-coordinate at my point is 0 equals the slope, which is still 2/5 times x minus the x-coordinate at that point was 5, and I get an equation. Now, can I somehow turn this into this? Well, absolutely. In fact, y minus 0 is y, and you distribute this, you would get the exact same equation in slope-int form. So you can go from point-slope form to slope-int form anytime you want. Okay? All right, now the third form is completely different. Whoops. And that's called standard form. And what that says is you have a little bit of x and a little bit of y combined together to make a total. Now that's not going to be obvious from a graph line. What I would say is if you're given a graph, you should instantly look at slope-int form, okay, or point-slope form, get an equation, and then if you want to rearrange the pieces, you can into standard form. I'll show you that right now. So I'll take this y equals 2/5 x minus 2, and I will get that into standard form here right before your eyes. Okay, now the first thing is I don't like fraction at all on this deal. So if I see a fraction, what I do is I look at the denominator and say I'm going to multiply everything by something that goes into to get rid of that. Okay? So I got a 5 here, I'm going to multiply everything by 5. Now, if this was 2/3 back here, then I'd be multiplying everything by 15. You pick the LCM of your denominators and you multiply everything by it, and you will eliminate all that division, okay? So here's what I'll have, 5y equals, these 5's will reduce, 2x negative 10. Now it's simply a matter of putting the x with the y over on one side, and I'll have it in standard form. So I'll simply minus away the 2x, minus away the 2x, and I will have negative 2x, positive 5y equals negative 10, and you can see why you wouldn't just get this out of thin air, okay? Because you do not see a slope, you do not have a y-intercept apparent to you when it's in standard form, okay? So it's definitely a different form, but I certainly would say you plug into slope in or point slope form, and you can certainly go into standard form without too much duress, okay?